Do you remember the Tower Pro MG996R full-size RC servo with metal gear? It was featured in an older mailbag, card here, link in the description. Anyway, I did an extensive review of it where I tested about everything, and there I learned it's a 360-degree servo. Not what I wanted, but if you want to see the review, card here, link in the description. Meanwhile, I acquired the Tower Pro MG995, a full-sized RC servo with metal gear inside, 180 degree, what I really need. It was also featured in a mailbag, card here, link in the description, and today I will put it through the paces. Speed, torque, a look at the innards, everything. But let's start with the basics. So what else do you get in the bag besides the servo? 4 different servo arms, so more servo stars and a servo disc. A single screw to mount these arms on the servo, and you get 4 rubber bumpers, 4 self-tapping screws, and 4 brass inserts for the rubber bumpers for mounting the servo. Dimension and weight, so about 20, and in the height about full height 44 and a half, and length about 40 and a half, and it weighs in at 57 grams. If we compare that with the specifications on the Tower Pro website, and I put a link in the description, everything seems to be roughly in order. Hi, future me here. Unfortunately, from here on out, things went south fast. Just a quick summary. I was unable to screw the screw into the thread here. And I had similar difficulties back then with the MG946R, but I was able to overcome that by a little bit of force, and the screw went in. But not so with at least my MG995. I resorted on recutting the thread inside here with a M3 tab. And as you can see, that's not really 180 degrees. Now, even if I let it just here turn around a 90-degree arc, you get this erratic behavior on the counterclockwise side. It's totally messed up. So I got another one from a different source. I will show the eBay listing at the end of the video, and I'll probably use some of the footage I shot with this dot here. Anyway, let's commence with the tests. Hopefully we've got more luck with this one. And right off the bat we have a better start, because I think, I just, started it by hand, but yes, the screw goes in without, any excessive force. This thread is just okay. Great. Let's start with the real testing. I control the servo with an Arduino Uno, which in turn is controlled by my laptop. Power to the servo is supplied by my lab power supply, which is currently set to 5 volts. And first I want to have a look at the PWM timings of that thing. So, most counterclockwise rotation we get at 2400 microseconds. And it starts to move back at 2390 microseconds. 2380. Middle position is reached at 2470 microseconds. And please note that middle position is not exactly 90 degrees. That's because Most clockwise movement we get at 440 microseconds, and that's again not full 180 degrees. That's just shy of 169 degrees, and it starts to move back at about not 550 microseconds, but did it move? I didn't see it. 540. No, 550, no movement. 560, it starts to move back. So this one shows similar behavior like the DAT. The timings are a wee bit different. The crossed out numbers were the numbers I measured for the DAT. It doesn't cover a full 180 degrees, just 169. So middle position is at 84.5 degrees. And but the PWM timings are basically the same. So 2400 full counterclockwise, and it starts to move back at 2390. And 540 full clockwise, it starts to move back at about 560 microseconds, and middle position, like the DAT, 1470 microseconds. So let's measure the speed of that thing. To do that, I'll turn it with the Arduino code to max counterclockwise and then back to max clockwise. And I'll give it a certain amount of milliseconds to finish each turn. And I will decrease the amount of time, maybe by 50 millisecond steps, until I can see that it's no longer able to do the full arc. So for example, we are currently at 1000 microseconds. I have to reset the Arduino to take the new command. And I can give it now, let's say 900 milliseconds. And it's a little bit faster and it's still working. And so on. So I'm running that test at 4.8 volts, and please note the idle current is about 10 milliamps. At 4.8 volts, it takes about 800 milliseconds for each full arc, full meaning 169 degrees. And this servo is much better behaved than the DAT before. And it's drawing, whatever instrument you want to believe. But I guess about-ish 150, between 100 and 200 milliamps with a peak current of 1.48 amps. This is a lot. The next test we run at 6 volts, and the idle current is still about-ish 10 milliamps. At 6 volts, it does the same arc in 650 milliseconds. And no of that erratic behavior. I want to point out that under these conditions, it draws short peak currents of 1.62 amps. But that's wildly varying. But if you just go by the bar graph or by the analog instrument, go that to the 400 milliampere range. 200 to between 200 and 300 milliamps. That's where analog instruments are really nice. So quite a current. So at 4.8 volt, we needed 800 milliseconds for a 169 degree arc. We draw about 100 to 200 milliamps with almost 1.5 amps peak current. And that translates into 0.28 seconds per 60 degree. At 6 volts, we were faster, so 650 milliseconds for 169 degree arcs. We've drawn about 200 to 300 milliamps with a peak of 1.6 amps. And that translated 0.23 seconds per 60 degree. and at 4.8 volts 10 milliamps idle, and so at 6.0 volts. Before we compare that with the specs, I wanted to point out that the servo wire length is specified at 32 centimeters. I only measured 27.5, and even if you take the connector in account and a little isolating stub at the body of the servo, I only get to 30 centimeters. But anyway, speed. So they say 0.2 seconds for a 60-degree arc at 4.8 volts. I measured 0.28 seconds. My measurements are not very precise, but they are not off 50%. Okay, I might be a few degrees off, let's say 5 degrees, and I might be 50 milliseconds off. I didn't tune that to the 10 milliseconds. But yeah, it's a little bit slower than specified. The same here for the 6 volts, where they specify 0.16 seconds for 60 degrees, and I measured 0.23 seconds. Again, my measurements are not that precise, but they are not that far off. Idle current, yeah, we always measure 10 milliamps. That is okay. However, a no-load operating current draw 170 milliamps. I say that's true for 4.8 volts, but that's certainly not true for 6 volts. So, let's measure the stall torque of that thing. I'm measuring, as before, here the amps and here the voltage. We start at 4.8 volts, and I have a little luggage scale here which we can tower out. That scale is connected via a string to the servo, and I will give the servo a full counterclockwise command via the notebook, and then we should be able, to read off how much force the servo is applying. One word of advice: my lab power supply, which is there in the background, can only supply up to 1 amp. And the stall current of that servo is specified at 1.2 amps. So yeah, we probably won't get the full torque, but at least an idea of what that little thing can do. Anyway, I will zoom during the measurements on that display, otherwise you won't see anything, and you just have to believe me how much current that thing actually draws. Okay, if I can, so that's 2,750 grams, and we're drawing, almost 1 amp. The voltage is a little bit down. Let's repeat that with 6 volts. I don't expect a different outcome, but anyway. No, we got a little bit more, 3,370 grams. And yeah, it's struggling, of course, and yeah, there's a lot going on, but it's drawing up to 1 amp. The servo arm I used during all this is 20 millimeters. So we got at 4.8 volts, a force of 2,750 grams with a 2 centimeter servo arm. That's not a divide, because that would be incorrect. And that translates to 5.5 kilograms centimeters. At 6 volts, we measured 3,370 grams with that servo arm, and that translates to 6.74 kilograms centimeters. According to the spec sheet, the stall torque at 4.8 volts is 9.4 kilogram centimeter, not divided by centimeter, kilogram centimeter. We measured 5.5 kilogram centimeter at less than 1 amp supplied. The spec sheet also states that the stall current draw is 1200 milliamps, which we didn't supply. Anyway, for 6 volts, it states 11 kilogram centimeter, and we measured 6.7 kilogram centimeter. Again, at less than 1 amp supplied. So the specs are not completely off here. I guess if you really give that thing 1.2 amps, you can reach these numbers actually. So let's have a look-see inside. Maybe we can fix the error. I have planned that segment for later, but well, let's do it now. So 4 screws holding it in, and they are retained. Okay, the motor, the electronics. Let me zoom down here a bit. Yeah, really not much to it. I mean, these two are properly, yeah, you see that big 2-pin stuff here, or 4-pin stuff. These are probably 2 power MOSFETs or multiple power MOSFETs, because you need an H bridge, of course, to drive that from a single voltage source in both directions. That brushed DC motor. There should be somewhere, and I can't seem to get that board out here. Can I? Just a sec. Okay, can I get the board out, please? Not from that side. So let's lift up the top, zooming out again. Filming here black body, it's drowning out, and lifting that up. And these are indeed metal gears. Who would have thought? Yeah, so at least that's true. That's the pot. That should be somehow, yeah, give you the position. I don't see any snap-ins. I think that board is just, what is it? A snap-in? I mean, if I destroy it, I destroy it. There you see the potentiometer. Ah, yeah. This is probably snapped in somehow. So there's basically nothing in these servos, and this is soldered in after the fact to the potentiometer. And I guess the potentiometer is simply, yeah, dodgy and giving a false feedback about the position. So I also promised you the eBay listing I bought the working one from, and that's I bought it from Funduino, to be exact, Funduino DE, the Servo Tower Pro MG995 180 degree for Arduino, Funduino, Raspberry Pi, microcontroller, whatever. And I paid for a single one €721, and yeah, free shipping. So, is that servo for you, the MG995 from Tower Pro? Well, if you are searching for a precision servo that's covering actually a full 180 degree arc, definitely not. Neither the working one here I got from Funduino nor the DAT from some Chinese source covered a full 180 degrees. This was a little bit less than 170 degrees. Otherwise, you get a dirt cheap servo. Yeah, for the last one I paid a little over $7 with a whole lot of torque. Okay, However, be aware that you might get a dud. I mean, this has no statistical significance. I bought only, that's the wrong one. I bought 2 of them and 1 was a dud. I bought a total of 3 Tower Pro servos in my lifetime and 1 of them was a dud. Maybe I can buy 1,000 more and that is still the only dud I ever bought. But yeah, obviously that's the proof there are duds out there. Anyway, that's it for today. Till next time, bye.